Okay. So remember, let's go ahead and review here. I did it right at the end of class last time, kind of the algorithm for this as a review. So we take our, for example, if we passed in the decimal value 10 into our function here, so our function is decimal to binary, so we're going to pass in a decimal number here. If 10 happened to be the number that came in for num, what we're going to have to do inside of this function is repeatedly divide 10 by 2, because we're going to binary, recording the remainder in a string. Okay, so you mentioned you put it in the string the wrong direction and then had to reverse it at the end, which is fine. I mean, it's not the end of the world. But we'll have to excuse me, we'll have to concatenate it onto the string here. Now, so we use the remainder operator. So let's experiment with that a little bit first. So we want to make sure we understand the tools we're about to apply to this problem before we just haphazardly start applying it to the problem. All right. So, when you go to Home Depot and you buy some new tool, you don't immediately, well, I guess if you're experienced and it's a replacement for the last tool you had, you might just immediately start using it. But if it's something brand new to you, you kind of have like your beta test with it, right? Same thing like with when you get like spot cleaner for like pet messes and stuff. They say, test it on a piece of carpet that's like under a couch or something first to make sure it doesn't turn your carpet, green or something like that. Okay, so we need to make sure we understand how these tools work so that we can trust them when we actually put it into our implementation. So let's just, before we even write this function up here, and remember, this guy is going to want us to do something, otherwise it gives us the error, so I'm just going to do a print LOL in here for the moment. That way we can experiment. This will be an untapped resource right now because we only have one element indented inside of it. Remember, these are comments, so they're ignored. So we're just going to come down here to kind of the main part of our program, even though we really haven't introduced the idea of main yet. We will when we get to objects, but this is the part of our program that starts executing, right? The thing that's far left indented. So we're going to go ahead and we're going to just experiment with printing a couple of values. So we want to say print, we're going to say 5 divided by 2, like that. We're going to say print 5, then 2 division symbols, and then print 5, where's my mod 2. All right, so we want to see the difference between these. We expect this guy to give us the remainder of the integer division 5 divided by 2. So 2 goes into 5 2 times, the remainder of 1. So we expect a 1 here. That makes sense? Now, these two we have 2 different tools we got. They look pretty similar to each other, but one of them has an extra little attachment on it or something like that. And we want to know the difference between these. In traditional programming languages, and we looked at this before, but in traditional programming languages, if you have 2 integers on either side, this one operator is treated as the integer division. So it'll always give you the truncated result. Okay? So we would expect in most programming languages that this guy would give us a 2. Because just 2 goes into 5 2 times with a little bit left over. All right? The reality is in Python we get the 2 here. Here we get, what is it, 2.25? What is 5 divided by 2? 2 goes into, it's 2.5. 2.5 times. All right, so this gives us the decimal division. This gives us the integer division. Let's go ahead and run this guy. I don't have my terminal open. Huh? No, that's not me. Or if it is, I'm not doing it on purpose. Sometimes I just omit robotic. I mean, it's the whole, more machine than man thing, and kind of more of a Terminator type of situation. All right, so I moved into the directory where my file is. I'll go ahead and I'm running this guy with Python 3 since I happen to have both versions of Python here on my machine. And I'm running test py. So there's our 2.5 from the single slash. There's our 2 for integer division. That's the guy we actually want. And then there's our 1 for our remainder. That make sense? All right, so here we'll put that higher so folks in the back can see it. Okay. So what we really need is we need stadium seating, right? Like the movie theaters, that's how it works in the movie theaters, right? So the people who sit, yeah, it's coming from somewhere up in here. I bet you they're working somewhere or there's a plumbing leak or a gas leak. So if I start seeing some of the smaller ones of you kind of pass out, then I know to. Isn't that why don't they keep parakeets like down in when they're doing
Canaries?
It's canaries. Yeah, that's you said that really strange.
I did say when I said it, I realized wait, I sound stupid.
Okay, yeah, when they're like when they're in mines and stuff like that, they keep a canary down there, and if they see the canary go down, then they all make a beeline for the exit. I wonder how many times the canary has died a natural death. And, they had this, big, panic where, it's like that canary was 19 years old. Actually, I think birds live a really long time. That might be a young death for a canary. I don't know. I know that parrots can live, 100, could be 100 or something. Old. All right. So, we kind of understand what our tools do now. So, we know that this dude is probably not what we want in this case. We want to use this tool because we want to control that integer division. We want to know that we get the remainder here, but we get the truncated product there. That make sense? Quotient. Truncated quotient there. All right, so we want to continually divide whatever value was passed in initially by 2. Recording the remainder, and then updating that value to be the next value down. All right. So after I take 10 mod 2, I get the 0. Then I actually want to replace the value of 10 with 10 divided by 2. Okay. That then is my next number I'll do through the loop. I want to keep doing that until I finally have a quotient of 0. That means I'm done. I can't divide anymore. It'll be an infinite loop, right? 0 divided by anything will just be 0 forever. All right? So that's where I stop. All right. Now, we could write this a couple of different ways. The correct type of loop for this would be a while loop. I think the book introduced while loops and for loops, right? Okay, so what we're going to do is we take our initial number and we're going to go ahead and we're going to say while num is not equal to 0. So we're going to keep going as long as num has not whittled down to 0. All right, in our example here, num started off at 10. 10 is not equal to 0, so we're going to do some stuff. All right. The first thing we're going to do is we want to do our modulus, do our remainder. Okay. We need to have some place to put it. So we're going to go ahead. We're going to create a string up here for our answer. Okay. So we're going to be building up a string for answer. If you look back here, this guy ultimately is going to be our answer. So we can think of this guy as being our string. All right, we're going to be building that string as we go along. Now, I'm going to purposely do it in the wrong direction first. The direction that is probably the most natural way for us to concatenate. All right. So the very first thing I'm going to do is I'm going to say answer is equal to answer concatenated with. Now, I want to do some math. So the math I'm going to do, and let's go ahead and we'll put it in a variable first just to make things a little cleaner. It's not necessary, but we'll do it anyways. So let's call this guy remainder, and we'll say remainder is equal to num mod 2. So the current value of num divided by 2 give me the remainder. That's what we'll store inside this variable called remainder. All right, and we want to take that remainder and we want to concatenate that onto our string. Now we've seen in the past that the plus symbol here requires that if we want it to work for concatenation, it requires both sides to be what? String stuff, right? Technically chars will work as well, but stringies, right? Okay, we've been introduced to two different conversion tools. Okay, we've been introduced to one that can turn a non-int into an int, and something that can turn a non-string into a string. Correct? So we want to concatenate onto our answer, which is a string, whatever answer currently is, because notice we're storing the result back in answer. So we're going to concatenate onto the current version of answer the string version of remainder. Okay? In a lot of other languages, what we would have done here, well, in a language like Java, this is allowed because Java is a compiled language. It's it's not an interpreted language. It knows that at least one of these sides at runtime, it knows at least one of these sides is a string, therefore it treats this operator as a string. In an interpreted language where this thing's running in real time, it's hitting this dude here before it gets to this one. So when it gets to this plus sign here, it has to assume that this guy here is well, it already knows that that guy's a string. So when it gets here, it's having to hope it's a compatible type. So the limitation they've put on it, they said it has to be a string type in Python. But strongly typed, high-level, compiled languages don't work that way because we know what type it is ahead of time. And when we compile it, we can abstract this and say, we're storing in a string concatenated with an int. And that's okay. We can then make the decision of, maybe behind the scenes, it's converting that int to the string. That makes sense? So our remainder here, this guy's numeric. He's a number. We're going to go ahead and convert him into the string version of himself. Now, in other programming languages, like a Java, just to kind of show you the difference between these, really it's not Java versus Python, it's an interpreted language versus a compiled language. So if we call this guy string remainder, this guy might be, in Java, the empty string concatenated with remainder, and that would be allowed. This is a convenient way of converting a number into a string in a language like Java. But because the concatenation operator doesn't allow us to have numbers involved in Python, we can't pull this off. But we have a nice little tool here that can do equivalently the same thing for us. All right, so we'll calculate our numeric remainder, get the string version of that remainder, concatenate it onto our answer, storing the result back in answer. So answer is one character longer than it used to be. All right. Then, after we've recorded that remainder, we do need to whittle down num. So we want num to equal num divided by 2, the integer division by 2. Now, it's important that we do this after we've done this. You don't want to whittle down num before you've already grabbed the previous remainder. Right? We need the remainder first. We need this value here before we get this value here. Does that make sense? Okay, we need it to happen in that order. So grab our remainder, use the remainder to concatenate onto our running answer, update num, then let it spin back up and see if we're done. Because num is now presumably a smaller value than it used to be. Now in our example here, it's 5 the second time through. Is that 0? Nope. Do your stuff. Now it's 2. Is that 0? Nope. Do your stuff. Now it's 1. Is that 0? Nope. Do your stuff. And this was our test stuff we had in here. Now it's 0. When it's 0, we know we're done. So we can fall past it, and our answer should be, in this case, roughly inside of answer. Okay? So we should see that right now our answer for 10 is actually 0, 1, 0, 1. It's backwards. It's in the wrong order. All right? But we're going to call that a strong move in the good direction, in the right direction here. All right. So in the end, we'll go ahead and we will return answer. And notice that answer is this return statement is not indented under the while. So this guy is not part of the while loop. He happens after the while loop has completed. You know, and if you want to give yourself some separation there, that's fine. That doesn't hurt anything. Okay, but make sure its indentation is in the correct place. In fact, I'd probably say this maybe makes the most sense. Give you one buffer line to give you some visual certainty that those guys are separate. All right, so here's our decimal to binary. It's going to convert our value, store the answer in answer, so building up a string inside of answer, ultimately returning the final value of answer. We can then do something with it. So for us, let's just go ahead and we'll print out the value of decimal to binary of 10. Okay, now we're hoping this guy gives us 1010. Okay. Okay, that's what we'd like it to do, is give us 1010. What we're actually going to find it does in this case is it gives us 0101. We've built it in reverse. All right, so let's go ahead and run this guy. So there's our 0101. Close. Yeah, almost there. So one thing we can do is we can go ahead and say, well, all I need to do is I need to reverse my string, and there's actually probably a reverse function built into Python, but I'm not necessarily aware of it. So because we're becoming real programmers now, if we need a tool to reverse a string, we'll just write a function to reverse a string. No problem. So we'll come up here and we'll call this guy reverse string. It'll take in a string as a parameter. I'll just take in an S. All right, and our job is to reverse that string. That means go from the end of the string to the beginning of the string, concatenating onto a new final solution. You can call it answer or whatever. That's what we've been doing. So we'll say answer is equal to the empty string. We want to now walk S from the end towards the beginning, right? So we saw this a couple classes ago where we can use that range function to give us a collection of values, but we can step by -1, right? So we're going to say for I in range, we're going to say S dot, no, it's not S dot length, it's length of S -1. That's the first position we want to check, the last legal bucket in S, all the way to 0 is the last place we want to check. So we're going to say -1 because we want it, the range function gives us non-inclusive. So if we said 0 here, it would actually stop at 1. We need it to get that 0, otherwise we're going to be missing a character. All right, so we'll say go all the way up to, but not including -1. And then we can tell it to step by -1. The default is to increment by 1. Now we're saying decrement by 1. Okay, so this for loop here should give us, if S had 5 characters in it, it should give us 4 all the way down to 0 for our counter. And then we'll go ahead and say answer is equal to answer concatenated with, and we can go ahead and get an individual string because the individual character, which actually is a string type. So we don't need to convert it. So we'll say S at position I, like that. And then ultimately we'll return answer. All right, so reverse string takes a string as a parameter. We need a new string in order to build up our answer. I happen to call it answer. We've been consistently doing that, but this guy does not need to be called answer. We could call that string to return or something like that, whatever makes the most sense. But we're building up our answer, so it kind of makes sense to call it answer. Then we want to go through all the characters in S. How many characters are in S? Length of S characters. Well, length of S characters is the number of characters. Last legal position is length of S minus 1. All right, so we'll give ourselves our blank slate to build up our string. We'll take I on a voyage from the last legal bucket in S all the way up to and including the first legal bucket in S, which will be 0, stepping by -1. So we'll walk backwards. Each time through, we'll concatenate on to answer the current character we're looking at, which should then, and when this loop finally ends, which means we finish with bucket 0 and finally become a -1, we'll return whatever we've built inside of answer. So what we can do down here is when we return answer, we can actually say return reverse string of answer. So notice that I'm actually calling another one of my functions from within another function. So decimal to binary, before he finally gives his final answer, he's calling reverse string, passing it the backwards version of answer that he created. All right, so this is a tool that we built. This is another tool that we built, and we have these guys kind of defined, and they're using each other. So now when we print out decimal to binary, we have the knowledge that this guy is calling that reverse string function right at the end before it gives me my answer. So now we should get our string in the correct order. So there's our 1, 0, 1, 0. Does that make sense? All right. Now, while it was all nice and fun that we gave ourselves the exercise of writing reverse string here, one pattern we want to notice here is that we've become fairly comfortable with concatenating this way. Updating a variable with the variable itself concatenated with something else. Nothing keeps us from doing that. Then I don't have to reverse it. I'm building it in reverse. This says, tack on my latest remainder onto the front of answer, stirring the result back in answer. Now, it's okay if you didn't do it that way because it's not a comfortable move for us, right? What we've learned up to this point is if we're building up a string, it's always the string equals whatever the string used to be concatenated with the new stuff. That's been our pattern, right? That's what we've been used to doing. You know, even though you can watch a professional carpenter do some really cool stuff with some of the same tools you have in your garage, you might not be able to pull it off, right? It's not in your comfort zone. Oh, and by the way, never use a power router. Yeah, don't do that. Okay? If you don't know what you're doing, do not use a router. Anybody in here ever use a router and knows what they're doing? Yeah, you know what you're doing? Yeah, you would agree with me, right?
Table one, though, not a portable one.
Yeah, but you would agree. Don't use one of those if you know what you're doing. Really bad. I cannot believe I didn't get injured. That thing went flying off. Then I got yelled at with my wife. I had to sell all my tools. Also a true statement. Anybody know Zach Rohde?
Yes.
Yeah, his brother is the one who bought my tools in that story. A whole garage worth of tools for a very, very low price because my wife said the tools had to go. All right, so let's go and test this. We'll see that now we didn't actually have to call our reverse string on this dude because we built it in reverse. Okay? So there's our correct answer without the extra step of reversing. But it was sure handy. I mean, might we find a use for a reverse string function later on? That could be something we could, you know, if I gave you a homework assignment that said, write a function that takes a string in and returns the reverse of that string, it wouldn't be that big a deal, right? Okay. So some extra practice. Now the question is, did you actually write a function to do this, or did you do it all in line here down at the bottom? Did you write a function to do your reverse, or did you just put the extra for loop down in here?
No, I used something else.
Oh, you use the built-in reverse? Okay. Yeah. So is it string dot reverse and you pass the string? Is that what it is?
No, it's the string, brackets, the double dots, and then -1 reverses the.
Oh, okay. Yes. Yeah. So that's called an iterator. It goes to the string. I think there's actually a function that does it as well. Here, let's see if we can.
I believe that function is just for using for loops, though. So, like, it doesn't reverse the string, it just goes backwards to the string. So you call reverse string in your for loop.
I want to try something here. Hello dot. No, doesn't like that. It definitely exists in Python 2.7. Oh well, my gut feeling is it's in there. Well, it is in there. It's just a kind of a weird syntax. Okay, but we built our own. No harm, no foul. All right. So next thing we might want to naturally do is we want to say decimal to octal. Right? That makes sense. So we can take this exact same dude here. We can write decimal to octal. Let's get rid of our comment here, because it's a little bit of a lie at the moment. Instead of modding by 2, we'll mod by 8. Instead of dividing by 2, we'll divide by 8. Ultimately, that's the only difference we needed to make. Now let's do our conversion in here first. So let's do 10 to octal. So 10 divided by 8, 8 goes into 10 one time. 1 times 8 is 8 with a remainder of 2. 1 divided by 8, well, is 1 equal to 0? No, it's not. 1 divided by 8, 8 goes into 1 0 times. 0 times 8 is 0 with a remainder of 1. We read our answer from bottom up, so this is 12 in octal. It actually wouldn't be called 12 because it's not decimal digits, but we can read it as 12. All right, so 1, 2 in octal is the answer we should get out of this guy if we converted it correctly. But again, notice that this was the identical pattern to what we just did for converting from binary, right? We just happened to do our modulus and division by 8 instead of by 2. So we should get our expectation is to get the string version of 12 there. And there's our 12. Okay, so that guy now works for octal. Okay. Now, what if we were converting from decimal to hexadecimal? What's going to change? Decimal to hex, and we'll go ahead and pass in my favorite decimal to hex conversion number, 2989. We mod by 16, we divide by 16. Okay, so we did the same changes that we made before. Okay, now we all know what should that number convert to in hexadecimal? Bad, B-A-D. Okay, so what we're going to see out of this guy is an 11 followed by a 10 followed by 13. Okay, which is not the right answer. It should be BAD. So let's go ahead and run this. There's our 11, our 10, and our 13, all glued together. So we took the 11 and we concatenated onto it the 10, we concatenated onto that the 13. We really needed to do some conversions on those 11s and 10s and 13s first. Correct? All right. So how can we do that? Okay. Tell me about these if statements.
If the number was not the remainder.
Yeah, so if this guy,
If the remainder equals one of those numbers, like you just start with 1, so if the remainder equals 10.
okay, so you can maybe start off by asking the question if the remainder is greater than 9, then we need to do some conversion stuff, right? If it's something other than our normal digits, we need to do some conversion stuff, and then we can throw if statements saying, well, if it's 10, it's an A, if it's an 11, it's a B, so on and so forth. All right, is there based on the tools that we have in our toolbox right now, is there a quicker way we can do this? Go ahead.
Couldn't you make another hex values string with values 0 through F? And then take the value at the index equal to the value of the remainder.
Yep. So we'll have a string that has all of our hexadecimal hextets, 0 through 9, and then A through F. And then rather than directly converting on a remainder, in fact, we don't need to convert it to string anymore because it's going to come out as a string, we're going to say hex at bucket remainder. So it says go to this string, get position remainder in that string. So if remainder was 0, the string at 0, the character at 0 is 0. If it was 10, the character at 10 is A. Character at 11 is B, so on and so forth. Does that make sense? So now we'll run this again, and there's our BAD. So we gave ourselves a little lookup table here that just had all the hexadecimal values in it, right? And then we said, go ahead and just, whatever our remainder was, let's look it up in that table before we just tack it onto our answer. And all of our lower digits work, and then all of our upper hextets also work. And with that in mind, we could also write a function decimal to base that maybe takes in a number, and the base we want to convert it to, or in the math terms, this is called the radix. Base and radix are like they're synonyms. All right, so we'll always mod by radix. We'll always multiply, or do our division rather, by radix. Now, we're making the assumption here that radix is something between 1 and 37. Otherwise, we run out of alphabet. So we'll go ahead and complete our alphabet there. And now we have something that will convert a decimal number, a positive decimal number. I don't want to get into converting negative ones because then we have to talk about 2's complement. You'll learn about that in 325 when you take that with me. That's the computer organization class. But we know how to convert positive numbers. All right. So we pass in any positive integer, and we want to convert it to any base south of 38. Okay, any base between 1 and 37. We need the whole alphabet now at our disposal for doing this conversion, and now this will do the conversion. So we can now call decimal to base, passing it 2989 and giving it a 16, and now it should do identically to what it did before, right? Because we know that the remainder here, num mod radix, will always give us a value between 0 and radix minus 1. So in this case, 0 to 15, because that's how modulus works. Okay, if we divide something by 16, the possible remainders are 0 to 15. You can't have a remainder of 16, otherwise that means you did bad division. The 16 actually went in an extra time. Okay? So we'll go ahead and run this, and we should get our same result, BAD. But if we wanted to, we'd say, let's go ahead and convert that guy to base 17 for no good reason other than we just wanted to see it in base 17. So there's the base 17 value of 2989, which is A5E. Make sense? All right, questions about any of that stuff? So let me give you our... This is the stuff we wrote today. Put that up on Slack. This is 200, right? Decimal to base stuff. Let's just go with that. With bonus points for our reverse function. All right, so now we've already been exposed to these, but let's go ahead and let's look at collections. Specifically, the first collection we're going to look at is something called a list. Okay. Lists in Python look like this. Something like that. So what we actually expect to occur when we call that range function is we expect the 1, 2, 3. If we say this in our range 0 to 10, we expect this guy to produce the lists 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Something that looks like that. So range actually produces this list for us. That make sense? All right, so we out at 50 or 55? 55? Okay, good. So let's go into our documentation over here. And let's go to the, what's this guy, right? So here's our lists in here. So it shows us what lists looks like. We can have lists of strings. We can have lists of numbers. We can have, well, here's a list of strings. Actually, both of these are string types. There's our evidence there. So list of chars, list of numbers, list of strings, whatever. We can see that accessing individual values in a list, don't worry about this syntax. Your book probably introduced it, but it's like a placeholder thing. We can access an individual value of a list by saying list, name of the list, and then that bucket, whatever, just like we did with strings. So really, strings are kind of like lists of characters, right? They act like that, with the one exception being that a string is read-only. Lists are read and write. So up to this point, we've recognized that as we are building, if we want to change a value in a string, we had an assignment a couple of classes ago where we had to change a certain position in a string, right? And we actually had to build a brand new string. We couldn't just go in and modify one bucket of the string. It wasn't allowed. Now, it is allowed with lists. So let's go in here. And what I'm going to do just to, well, I guess we'll just keep going. So I'm going to go ahead and say LST is equal to 1, 2, 3, 4, 5. We'll go ahead and we'll print out LST. And we'll see that it knows how to print that list. So there's my 1, 2, 3, 4, 5. Okay. Now let's say I wanted to change bucket. Well, let's say I want to get bucket, the bucket that has 3 in it. This is bucket 0. This is bucket 1. This is bucket 2, bucket 3, bucket 4. So I want to go ahead and I want to print out just bucket 2, which should be a 3 in this case. So it's indexed just like strings, 0 to length minus 1. So I'm going to go ahead and let's say just give me bucket 2 from that list. All right. So there's my 3, the value that lived at bucket 2. Now, something we couldn't do with strings is if I want to change bucket 2 there to a 7. And then I'll go ahead and I'll print out the whole list again just so you'll see that it actually changed. So I'm going to say list at bucket 2 gets the value of a 7. This 3 now gets overwritten by a 7. So there's my list with that one element replaced. Okay, so if strings had worked like that, that one assignment I had given you would have been pretty easy, right? It's like, oh yeah, you wanted me to change bucket bucket num to the new character you passed in? String at bucket num equals new character. Done. Move on with life. All right, so that's an advantage of arrays. Well, lists are often called arrays in other languages. Okay, so if we want to draw some parallels here, these are our arrays in most of our strongly typed languages, Java, C#, all those, they call them arrays. Okay, so go back in here. We already saw updating something in a list. We can also delete an element in a list, make it smaller than it used to be. So I can come in here and I can say, after I've added the bucket 2, I can go ahead and do delete LST at 2. And then print out LST. And there is LST with one less element in it. So I kind of wasted my time changing bucket 2 to a 7 if I was just going to go ahead and delete that entire bucket the very next time around. Okay, but what I can tell you though is even though this seemed very easy for us to do, delete that value, it was actually quite destructive. Okay, a lot of stuff happened with memory behind the scenes when we did that deletion. And we're going to talk about that aspect of it in detail next class. I wanted to show you these primitive types first. We can get the length of a list, just like we got the length of a string. We can concatenate lists together, using the same thing we used for concatenating strings, just both sides need to be lists. We can actually do repetition, which I don't find all that helpful very often. So you can use the multiplication symbol to create a list that, the list high times 4 gives you the, and that actually works for strings as well. You said the string high times 4, you would get the new string with high in there 4 times. I don't know how useful that is, but it's a thing. All right. We've already seen this guy, right? We've seen this is actually a Boolean expression. Boolean expression, any expression that boils down to a single value of true or false. So this is an expression that goes ahead and it returns true if this value is found inside of this list. And we've been dealing with that all along with for loops, right? Is this guy in this range? Okay. They're showing it here. This is that example. Okay, so we can go through every element in a list. All right. Now we have a function called list append. Okay, and this is the guy I'm going to show you just real quick, just so you have enough to do our homework assignment. So I'm going to start off here with the empty list. And I'm going to go ahead and I'm going to say list.append. And we're going to pass this guy a 1. Two, then 3, and let's go ahead and print out list. So there's 1, 2, and 3. So append adds a value onto the end of a list. Does that make sense? So we can start off with the empty list, and we can append values onto it. So just as a little practice exercise, and hopefully this should be a pretty easy assignment, we want to say string to list. We're going to write a function, string to list, that takes a string as a parameter, and this guy returns the list version of the string s. For example, LOL should turn into the list LOL, like that. That make sense? All right, so this is just using those basic primitive types of our lists. So I'll go ahead and I'll post this stuff up on Slack, just so that should give you the besides the stuff you already know, this should give you what you need to do this assignment. Okay, so this assignment is just getting you used to lists a little bit. All right, questions, comments, concerns, bribes. All right, I'll see everybody on Friday.
I actually do have